Okay, so this video is going to be a little bit without any context whatsoever, but at some point you are going to need to use factorials, and factorials will lead into needing to use combinations and later on permutations. For now though, let's just examine what is a factorial and the notation for it. So a factorial is indicated by the exclamation mark. It's often accompanied in comic books with somebody firing a gun and saying bang. So sometimes people call this bang. So they'll say something like 3 bang or 3 factorial if you'd like to be more professional about it. Now, what is 3 factorial? Well, 3 factorial is 3 times 2 times 1 times 0 factorial. And so it's actually, this is always going to be the same number. It's starting with this number, multiply all of the integers all the way down until you get to 0, and then multiply by 0 factorial. Now, this brings up a question, what is 0 factorial? And I guess I should put a question mark after that, which makes it just kind of look a little bit like I'm swearing on this video. I'm not. 0 factorial has to be 1. And it's that by definition. Otherwise, when we get down to multiplying by 0, every factorial would just turn into 0. And it's so often that when people teach factorials, often they just ignore that part. And so they would say something like 5 factorial is equal to 5 times 4 times 3 times 2 times 1. And they wouldn't write the 0 factorial. And that's okay. Another interesting thing about factorials is suppose you had 5 factorial, which we do up here. We could write this as 5 times 4 times 3 factorial, because every factorial is contained within every larger factorial. See how 3 factorial is 3 times 2 times 1, and that's contained in 5 factorial? So we would say that 5 factorial is 5 times 4 times 3 factorial, or we could say that 6 factorial is 6 times 5 factorial. So that's just some arithmetic that you can do with factorials. By the way, you should have a few of these memorized. 1 factorial is nice and easy. It's just like 0. 2 factorial is pretty easy as well too. 3 factorial, rather than doing 3 times 2 times 1, I'm just going to multiply the previous factorial by 3. Now I'll just multiply the previous factorial by 4, then by 5, then by 6. And I could keep going, but really that should be enough of a set of factorials for us. You can see that these get pretty large pretty quickly because it's actually growing at a faster rate than an exponential function, because each time you multiply, you're multiplying by a number just slightly higher. So initially, it would seem as though an exponential function would be fast.